Dear students, Assalamu alaikum. Today our topic is median. So far we have discussed how to find mean and how to find median in all the series, whether it was individual series, discrete series or continuous series. Now we will find how to find median in case of all these series, whether it is grouped data, that means individual series, or whether it is individual series or discrete series, grouped data or ungrouped data. Now before going to proceed further, I will explain a concept that will be used in finding median in case of discrete and continuous series. That means in case of grouped data, that concept will be used. So before going to explain what is median and how to find it median, I will explain what is cumulative frequency. Cumulative frequency. Suppose your data is x is given as 3, 7, 8, 9 and frequency is given as 4, 5, 2, 10. Then cumulative frequency, you have to find cumulative CF. In short, I can write CF, cumulative frequency. Cumulative frequency we can calculate it means summing the previous frequencies. For instance, first frequency is 4. Prior to this, there is no frequency. So cumulative frequency of the first frequency is 4. Now the second frequency is 5. Prior to 5, there is one frequency 4. So add prior frequencies, 5 plus 4, you will get 9. Then after that, next frequency is 2. Prior to 2, 4. So 2, 5, 4, 5, 4, 9, 9 or 2, 11. And prior to 10, the frequencies are all, summing all. That means summing up to this. So 10 plus 2 plus 5 plus 4, 10. Prior to 10, there is 2, 5, 4. So 2, 5, 4 or 10. That means 21. So that means last number of the cumulative frequency will give also summation, because last cumulative frequency of last number is sum of all frequencies. So you will get summation f equal to 21. This concept, we will use this concept in discrete and continuous series, that means grouped data. Now we will come to the main topic, that is median. Median is a positional average. It is a positional average. Positional average. Median is a positional average, where x bar, arithmetic mean is a mathematical average. Mathematical average. So actually, before going, median means the middle term in the data. For instance, when that data is arranged in an order, whether that order is ascending order or descending order, whether you arrange your data in ascending order or descending order. After arranging the data in ascending or descending order, median is the most middle term of the data. That means 50% should lie below the median and 50% of data should lie above the median. It means that is it is the central central value of the data, so that 50% data is above it and 50% data is below it. Above it means 50% data is 50% data is more than median value, and 50% value below it means 50% data will be more than the median, less than the median value. Let us now calculate how to calculate median in case of individual series and discrete series. In class 9th you have already calculated median in case of individual, but let us have a look to individual series once again. First data is 3292184. Data is 3292184. First of all, you have to arrange this data in increasing or decreasing order. So when we arrange, I will first write 1, then 2, it is once again 2, then 3, then 4, then 8, and then 9. So here number n is number of observation. Number of observations are 7. So number of observation n, that means odd. When number of observations are odd, median m equal to n plus 1 by 2th term. N plus 1 by 2th term. This is formula for median when n is odd. In case of individual ungrouped data, yani ki individual series, so m equal to n plus 1 by 2th term. Now n is 7, so median equal to 7 plus 1 by 2th term. That means 7 plus 8 by 2, 4th term. When you look at the data, arranged data, 4th term, 1st, 2nd, 3rd, 4th term is this. If you also look from here, whether you count the 4th term from left or from right, you will get the same value 3. You will get the, so median is 4th term, that is 3. Median is not 4, it is the 4th term. So median is 1st, 2nd, 3rd, 4th term. 4th term 3. So median is 3. Now if you look, median is 3. 50% data is below this, that 2, 2 and 1. So 3 values are below this and 3 values are more than this. So that is why I explained it in definition that median is the central value. 50% lies below this and 50% lies above this. So 3 is the median. Now if instead of even the number of terms are odd, how to calculate median in case of individual series then? So we will give another example in case of number of terms are odd. Even suppose the terms are 3, 2, 4, 1, 0, 6. 1, 2, 3, 4, 5, 6. The number of terms are also 6. So it is an even number of terms. Now first of all you have to arrange the data. When you arrange it, first I will arrange it in increasing order. I will write 0, then I will write 1, then I will write 2, then I will write 3, then I will write 4, and then I will write 6. So this is the data in arranging form. Here n is 6, n equal to 6, that is even. Median equal to, right? Remember this formula. N by 2th term plus n by 2th term plus n plus 1 by 2, n plus 1 by 2th term divided by 2. That means you have to take 2 terms. First n by 2th term, then then a term more than one of this term, n by 2 term plus 1, a term one term more than this, n by 2 plus 1, n by 2 plus 1 by 2. The n is 6 by 2 3, n is 6 by 2 3, 3 plus 1 4. So you have to take third term plus fourth term, third term plus fourth term divided by 2, average of third term and fourth term. So third term and fourth term, third term first, second, third term is this term and fourth term is this term. So the two terms are, third term is 2 and fourth term is 3 divided by 2. You will get 3 plus 2 5, 5 by 2 2.5. So the median is 2.5. Now if I see median is 2.5. Now if we look at this 2.5, 3 terms are less than this, 0 1 2, 3 terms are less than 2.5 and 3 terms are more than 3 4 5, 3 4 6, 3 terms are more than this. This means median may be a value in the data, or in previous example we got a median which was in the data. Now here we got median 2.5, that is not in this. So we conclude that median can be a value which may be in the data or it may not be in the data. But one thing is sure, that 50% will lie below this and 50% of values will be lie above this, more than this, and 50% will be less than this. So median is 2.5. So in case of even term, when you are finding median for individual series, you have to find median n by 2 term plus n plus 1, n by 2 plus 1 term divided by 2. Here n is 6 by 2 3, 6 by 2 plus 1, that 6 by 2 3 plus 1 4, fourth term. So third term and fourth, not 4 3 and 4, third term and fourth term by 2. That means third term is second 2 and fourth term is 3. 2 plus 3 5 5 by 2 2.5. So you got, this is how you calculate median in case of individual series, whether the data is number of observations odd or even. Now we will calculate median in case of discrete, series and individual continuous series. So we will get an example. Suppose marks are given as 3 2 5 8 4 and frequency is 218 8 3 6. So the frequency is this. As I have already told, this is here the numbers are whole numbers, so it is and there is also frequency, so we can term this as discrete series. This is known as discrete series or grouped data. So discrete series, 3 marks to 2 students, 2 to 1, 5 to 8 students, 8 to 3 students, and 4 to 6. Now as I have already explained, you have to, before for grouped data, that means discrete series and continuous series, you have to also find cumulative frequency, and I have explained you how to find cumulative. That means 2, prior to 2 there is no value, so 2 will be the cumulative frequency. First frequency is 2. For second frequency it is prior to this 2, 1 and 2, so you have, that is 3. 8 prior to this 1 and 2, so 8 1 and 2 11, and 3 prior to this 8 1 2, so that will be 14, and prior to this 6, prior to 6 this is 3 8 1 3 8 1 2, so prior to this is 6 3 8 1 2, add, you will get 20. So the total, that means summation f is also n equal to here summation f. In case of individual series we take a number of observations, but in case of discrete or continuous series, summation f is n is summation f, n is summation f, because n equal to summation f equal to 20. Now what you have to, here n is if n is odd, 20 is to or even. Here n is even, so you have to take median equal to for even it is n by 2, as I have explained, n by 2th term plus n by 2 plus 1th, n by 2th term plus n by 2 plus 1th term. You have to calculate n, first n by 2, n by 2th term, that is 20 by 2, that is 10th term, 10 and 10th term, and n plus 1 by 2th term, that will be equal to 10 by 2, n by 10, 20 by 2, 10 plus 1, 11th term. Now look at the 10th term and 11th term. If you get, you have to see this 10 and 11, what you get by n, calculating n by 2 and n by 2 and n by 2 plus 1. You will get 10 here. You have to look it in the, which is the minimum cumulative frequency in which 10 is contained. 10 is not contained in 2 because it is less than this. 10 is not contained in this because it is also less than. 10 is contained in 11. So you have to, so 10 is contained in 11. You have to take the value against this cumulative. So the value is 5. So you have to take 5 plus 11 is contained in 11. So once again you have to take 11th term, n plus 1 by 2, that is 11th term. 11 is also contained, so you have to take once again 5. So 5 plus 5 divided by 2. 5 plus 5, 10 by 2 equal to 5. So the median is 5. That means in case of discrete series, median is once again the same. Median equal to n by 2th term plus n by 2 plus 1th term divided by 2. So median is equal to n by 2th term plus n by 2 plus 1th term divided by 2. But you have to first calculate n by 2, that means 20th term 20 by 2. So 10th term plus 10 plus 1, 11th term divided by 2. But remember, you have to see 10th term in which it will contain from in cumulative frequency column, not in frequency column. So 10 is less than 2 is less than this 10. 3 is also less. It is contained 11. So you will get 11 corresponding to this. You have to see the value. So that is 5 in the variable. Here it is marked, so it is 5 plus 11th term. 11 is also contained, so you will get once again 5 divided by 2. 10 by 2 equal 5. So you got 5 in the middle. This is how you calculate median in case of cumulative, in case of discrete series. Now let us take a question from continuous data. That means when it is in class interval, when class intervals are given. Suppose this is sales in rupees, thousands. Sale is in thousands. Two to 4, 4 to 6, 6 to 8, 8 to 10, and frequency is 6 to 8, 3. you have to calculate the median sales. You have to calculate the median sales in this question. Now first of all we will find CF, cumulative frequency. Prior to 6 there is none, so 6 is same. 6 plus 2 8, 8 plus 8 16, 16 plus 3 19, 16 plus 3 equal to 19. Now formula for median in continuous is L plus n by tooth term minus CF divided by F into H. So remember this formula for median. For continuous series you have to find median by this formula. As in case of mode in discrete in continuous series, we were finding first modal class interval. Here we will first find median class interval, then we can determine L, F, CF and H. H is the class size, and L, F and CF will be found in the median class interval. How to find median class interval? For that, first of all calculate this n by tooth term. N is summation F, and obviously last term of the cumulative frequency is summation F. So summation F n equal to summation F equal to 19. So first of all you have to find n by 2. N by 2 means n by 2 equal to 19 by 2. That means 9.5. So what you got? 9.5. Now you have to once again see in which cumulative frequency 9.5 contains. 9.5 is greater than 6, so it will not contain in 6. 6 में तो आएगा ही नहीं क्योंकि 6 इससे कम है. 8 में भी नहीं आएगा क्योंकि 8 भी इससे कम है. But it will contain in this. So underline the class interval corresponding to this cumulative frequency in which 9.5 lies, and you have to see the minimum value. Otherwise 9.5 also lies in 19, but you have to find the minimum value in which n by 2 value of n by 2 lies. Value of n by 2 is 9.5, and 9.5 will lie in not in 6 because 6 is less, not in 8 because that is also less, and it will lie in 16. Minimum value is 16 in which 9.5 lies. So corresponding to this, underline this column. Now as you know, in case of mode, same is here. L is the lower limit. L is the lower limit of this curve. Lower limit. L is lower limit. So L equal to 6. So L is lower limit. L is 6. Now I will calculate mode. Mode equal to L is lower limit of this class. That means L is 6. So I will write 6 plus n by 2. I have calculated 19 by 2. 9.5 minus CF is cumulative frequency below that class. That means modal class F frequency, cumulative frequency below this class. So below is where it is decreasing. So 8 is the cumulative frequency. Cumulative frequency of this class is 16. इससे below जो है that is 8. 8 is the cumulative frequency below where it is decreasing, not where it is increasing. So it is decreasing in this order. So the first one is 8. So 8 is the cumulative frequency below this class, divided by F is frequency of the modal class, and frequency of the modal class is also 8. That is 8. F is frequency of the modal class, that is also 8, into class size is 4 minus 2, it is 2. Class size is 2. So you will get 6 plus, after calculating this 9.5 minus 8, it is 1.5. 1.5 divided by 8 into 2, you will get 0.375. 0.375. So 6.375 is the median. 6.37, and obviously it lies in this interval. So 6.375 is the median. This is how we calculate median in case of continuous data. I hope you have understood this, how to find median in case of continuous series, discrete series, and individual series. And if you have any question regarding this, you can write it in that question comment section. And also remember one more thing regarding median. Class intervals should always be continuous. If class intervals are not continuous, you can't find. Suppose if class intervals are 0 to 3, 4 to 8, 5 to 9, 6 to 7, 10 to 12. In such case, you can't find median or mode. First you have to make it continuous. But that such type of question are not in your syllabus, in your book, and you will learn such question in higher classes. Thank you for watching. Thank you for watching this video, and stay safe, stay at home.